Hello, welcome to the Logic Gates presentation. Today I'm going to demonstrate the properties of the NOT gate. I designed this demonstration for a friend who is an electrician. He was wanting to learn more about logic gates because of his interest in PLCs. Here we have the symbol that represents a NOT gate. You can see it only has one input and one output. The output depends on the status of the input. Here we have the truth table. It represents the status of both the input and the output. As you can see, all the values are zeros and ones. This is due to the fact that logic gates use a binary number system, which is based on 2. So there are only 2 numbers. The reason why is very simple. Logic gates are basically made of switches. There are only 2 states for a switch, on or off. The on state is normally represented by a numeral 1 and the off state is represented by a numeral 0. Also, the on and off state can be represented as true and false. For this demonstration, I will be showing the status of the input and the output today as true and false. Here, I used a momentary push button switch to represent the input of the NOT gate and a light bulb to represent the status of the output. Whenever the light bulb is lit as it is now, this represents a 1 or a status of true. Whenever the light bulb is off, this represents a 0 or status of false. If you observe switch A, you will see that it is currently open, representing the input of false. In this state, current will not flow through the switch. But now observe switch A. It is now closed. This represents an input of true. In this state, current will flow through the switch. The NOT gate is also known as an inverter because it inverts whatever the input is. To represent this phenomenon, I am showing a relay here in the circuit. This relay will do the job of inverting the input. Here you can see when the switch A is closed, representing a true input, then the current will flow through the switch, energizing the coil of the relay. Notice the dotted circle around the coil. This represents the magnetic field that is created by the energized coil. This magnetic field then opens the normally closed relay contact, causing the light bulb to go dark, representing the output of false. When you have an input of false, the relay coil is de-energized and the relay contact closes. As you can see, power then flows through the relay contact, energizing the light bulb, representing the output of true. Here in the truth table, you can see that whenever input A has a status of false, the output is then true. When the input is true, you have a output of false. I hope this has been a help to you, and I plan to follow up with more examples of logic gates in the future. Thank you for watching.